Everything for the editor assembler module is on disk. The editor and the assembler, the two main functions of it, are all on disk. And they load themselves into low and high memory expansion as you use them. Go ahead.
Let's say you've got an extended basic program and that uses some assembly language subroutines.
Okay.
What I'd like to do is take and modify the save to disk program so it saves the whole block.
Oh, okay. It's very possible to do that.
Yeah, I know.
Okay.
But what locations does that?
Ooh, okay. Let me take this down for a second. Basically, the question was, you have an extended basic program, and also this program you load some assembly language subroutines through call load, and generally they load themselves into low memory expansion. And what you want to do is you want to get them into high memory expansion. So the first thing you have to do is modify your subroutines to A-origin them down to here. Okay. Now what you're going to do the first time to set this thing up is, let me get a piece of chalk. What you're going to do the first time is first you're going to A-origin your assembly language program. So we'll start with that. Okay. That's the first thing you're going to do. And you have to make sure that when you A-origin, you don't put one on top of the other naturally. Okay. And you want to make sure also that they do not go lower than FFE7. That's the end of what Extended Basics considers its normal memory space.
So you cannot go lower than that?
Yeah, no, you don't want to go to FFE8. You don't want your program sitting down there. Okay.
Higher.
I look at the map. Down. Lower. I go through this all the time. Okay. So then after you have them all in there, now you're going to be putting them in there by manually typing in call loads at this time. Okay. After you have them in there, then what you want to do is, in order to get them run, to be able to access also now. Now, after those are in, then go ahead and we've got to change a couple pointers now. So get your paper out.
You only have to change the one at the beginning of the load. Jam of this
Well, we're also looking now to load an extended basic program in on top of it.
Well, what you're going to end
right
up
below
with
the basic.
Oh, you could change this.
Right below the extended basic line pointer table and change the pointer to the highest free address.
Highest free address.
That's all you should have to do, and then it should all save as one block.
Right, but also you got to point to the link table too. You have to change the link table too.
Oh, yeah.
Yeah. So
it won't save it.
no, yeah, no. Okay. Hold on.
Other than you reserve book or anywhere in this information?
No, not till I finish the memory maps in the newsletter. All right. Excuse me for 1 minute while I look this up.
I think you have to do the link table by call load and direct focus to the memory. There's no way you can save the link.
No, yeah, that's going to have to be moved. Yeah, that's going to have to be saved up there.
You have to put the link table in the basic program as direct call.
Call loads, right. At hex 8386 is the highest free address in memory expansion. Okay, so after you've loaded these programs in, then go in and find out where they are now. They're up in here someplace. And change that pointer at 8386 to represent now where the new...
Well, that's in hex.
This is in hex, yeah. What do you want, decimal?
No, that's in a pad. Scratch pad.
Yeah, scratch pad.
Actually, the
Oh, yeah.
order looks at 2002 and 4.
Wait a minute, we're not there yet. We're going to get there. First I'm going to get it so you can save this thing all in one block.
That's what I'm saying.
Yeah, okay. So basically we started here at FFE7.
Yeah.
Okay.
That's where
All right, now you've done call load and loaded a bunch of files in here, and so now they're let's just say they're about here. Now let's say that this address now is just for here, say FF00. So add that hex 8386. Change that so that it now holds FF00. Okay. So that would be, you want this to be 1 byte less than where your program was. You can have a few extra in there, it won't hurt. Okay. Then go ahead and load your extended basic program.
After this?
Yeah.
After the call loads? Or?
Yeah. Because now you've changed the pointer to the first free address. And so when your extended basic program loads, it's going to start down here and load up to here someplace. Now you've got the whole thing in memory. Now go back to 8386 and change it back to FFE7. So that tells extended basic that now this is your whole program. We've fooled it now. Okay? Then once that's done, you're going to have to also, though, add to the top of your program the call loads for the link names. You're going to have to manually call load those link names into the ref-def table where they belong. Okay. And in there, what you want to do is, you could do it another way.
You can change
that.
ref-def table.
You can move your ref-def table down to here, yes, by changing the address up in low memory. So if you move them down there, you need to change. Hold on a second. I'll give you that address. Well, you have it in the newsletter.
2004.
Yeah, 2004. Yeah, not 2002. That points to where the routine is that starts scanning. Yeah. Yeah, that's what. No, first. Hold on.
That table was above the last free address in...
Last free address in low mem. Yeah, 2004. Right.
Yeah, you got to put it in low memory expansion because that's the only thing that uses the key to the ref-def table.
You can change the pointer to the ref-def. Yeah, and it does work. It will link down there.
I mean, even if you put it up in the upper memory expansion, just put it in that address.
Yeah, and it will work. You have you have to be above 4,000. If it's the routine that does the scanning says, is it equal to 4,000?
Yeah.
If it is, it says there's no ref-def. But if you're greater than 4,000, it'll go down there and find it. They didn't do a jump of less than or whatever on that one. They checked for equal. So that's after you change that pointer to the ref. If you move the ref-def down here.
Well, that's what I've been doing.
Okay. Then, yeah, with the original weather, then just change that pointer to 2004 and it'll run. And so the first program would be a call load at 2004.
Well, it's the save routine that I needed to take.
Once you change this back to
Save it, the loader will load it back in.
Once you change this to FFE7, then just save it. And it'll save the whole block now. Okay?
That's what's called embedded code.
Yeah. Well, it loads faster that way.
Oh, yeah.
It's all program image then if it doesn't get too big.
You don't have to have call loads.
All those call loads. And loader and extended basic is a real snoozer. Yeah. So, next. Yes.
I think I had said the disk buffers of 256 bytes.
Yes, per file.
Is it possible to change that, or is it enough?
No. No, it's been set up in the disk controller DSR. The question was, can we change the size of the buffers, the disk buffers, which are fixed at 256 bytes? And no, because that's burned into the DSR ROM, and that's also a sector size. So that's one of the reasons why those two stay around that same size. The buffer could get larger, and we just divide it up and then say, well, we just write 3 sectors at a time, or 4 sectors at a time. But it's just the way the DSR knows. You have to change the whole DSR around. And if you did that, then it wouldn't be compatible with any of the old stuff. And so it would be a real mess. Okay? Any other questions?
Incidentally, that is what the hard disk does. It does 16 sectors, a 4K buffer.
Oh, yeah, it's got that 4K buffer on board, doesn't it?
Yeah.
Yeah.
I understand there is more information on a disk than what's written on the sector.
That's true.
How do you access other bytes?
You want to just read them?
Yeah, just read them or change them.
Oh, advanced diagnostics will read them. As far as changing what's in between the tracks, it's real dangerous. We did not allow a track edit in advanced diagnostics because if you get one bit out of whack, you'll never read that track again. Whereas if you're doing an edit sector and you change a byte in there and you write it back out again, you can always read the sector back in. You can say you haven't lost anything. But if you change one bit, if you change certain bits in a track buffer and you write that track back out, there's a good chance you'll never read it in again and it's all gone. So you just lost 9 sectors.
I looked at some disks with that program, and there'll be several sectors will be used, and then there'll be one sector you can't read. And then we skip over, and there's more sectors you can read.
Yeah.
How do
Oh, that's a piracy question. No, I'm just kidding. How can you get to that sector? I don't know. You have to know the address of it and bypass certain routine. You have to write your own routine to get to that sector.
Have you tried the track access for that track?
Oh, read track is yeah.
Read track. What did you get?
Well, he found an extra sector someplace. He found a 10-sector track. It sounds like. And you can't get to the 10th sector, right? Because after, well, see what it is the routine, no, the routines that, on a disk, on a track, all the sectors on every track are normally numbered 0 through 8. So that's 9 sectors per track. And all the routines in the disk controller card and the other ones that are written out there calculate what sector number to be at by multiplying 9 by the track number.